Well, in this video, we may have the longest title of the whole page of videos here, Applying Laws of Exponents and Distributive Rule to Write Expressions in Forms Convenient for Calculus. Well, what does that all mean? First of all, the first examples we look at are going to be in the form of a, where a is just some number, x is a variable, and n is another constant or exponent. So ax to the n is a convenient form for calculus. It's one of the simpler types of functions that you encounter, and so we want to be able to practice in writing things that can be written that way. So first of all, what do I mean? Here's some examples. 2x to the 7th. In that case, a would be 2 and n would be 7. Okay? 3 halves x to the negative 5. In this case, a would be 3 halves and n would be negative 5. So that's the idea. We want to get something, we want to start with whatever expression we're given and see if we can write it in this form, ax to the n. So the first example is 5 divided by 2x cubed. So that's the expression we have, and we want to write it in our convenient form of a number times x to some power. Well, when you look at this, you need to, or one way to think about this is to recognize that this is a fraction, but we could also think of this as being made up of other simpler fractions. For example, this 5 in the numerator, we could think of that as being 5 over 2, and then the other fraction that we would need to multiply by that to get 5 over 2x cubed would be just 1 over x cubed. Now, that's not the only way you could split it up, but I'm splitting it up that way because it's going to get me to where I'm trying to go, that is ax to the n. So right away you can see we have a number a here, 5 halves, and if we could just write this 1 over x cubed as just x to some power, we'd be done. And that's exactly what you learned in the last module, or perhaps you knew this already. 1 over x cubed is x to the negative 3 power. And so now we have a as 5 halves and the n as negative 3, and we have ax to the n. Okay, so and when you get when in calculus you'll find out that if you can write something in this form, ax to the n, you can work with it a lot more easily than in the original form. Now, second example. This time let's take 7 over the cube root of x squared. And I want to write it ax to the n. Now again, still thinking about it, and you don't have to write all of this, but I'm still thinking about it as I want to separate my numbers and my powers of my x. So I have 7 over 1 multiplied by 1 over the cube root of x squared. So now the 7 over 1 is just 7, and so I can just say 7, and 1 over the cube root of x squared. Well, there's two steps in the thought process here. The cube root of x squared we saw before is x to the 2/3, so I'll put in the two steps. So the first step is to recognize that the cube root of x squared is x to the 2/3. So I have 1 over x to the 2/3. And then 1 over a power of x is the same as the power with the exponent changing sign. So this would be x to the negative 2/3. 7x to the negative 2/3. Again, we've got the a, the x, and the n. N is negative 2/3 in this case. Now, in each one of these examples, if you want to get the most out of this, now that you've seen an example or two, you want to pause. There's a pause button on the video. You should pause and see if you can work it out, and then see if you agree with what we end up with in the video. So, the next one, 1 over the square root of 7x. And 7x is under the square root sign. Okay? So, now there's a couple of ways to go about doing this. Again, you should pause before we do this and see if you can come up with something. Now, one thing, I guess, one way to look at this is that we've got a 1 over something, and so if that was something was a power, then we could just use our laws of exponents. So, for example, we know the square root is, in this case, the 1/2 power. So this would be 7x raised to the 1/2 power. So 1 over that. Now 1 over that would just be 7x raised to the negative 1/2 power. Now, you say, well, we're done. A is 7, and then n is negative 1/2. But not quite yet, because the 7 is not really just a 7, it's inside this parentheses, and that parentheses has a negative 1/2 exponent on it. But we had a law of exponents that says if you have different bases and you raise them to a power, you can raise each base to that same power. And so, that would be 7 to the negative 1/2 multiplied by x to the negative 1/2. Now, 7 to the negative 1/2 power is a number. It's 1 over the square root of 7. So you could write it like that if you wanted to. 1 over the square root of 7. And that's a number. And then we have our x, and we have an exponent on the x, in this case negative 1/2. And so now we have a, 1 over square root of 7, times x, and x is raised to the negative 1/2 power, so n is negative 1/2. So that's one way to leave the answer. You should not have stopped, though, with the 7x to the negative 1/2, because specifically the form is a number times just an x to the to a power, in this case negative 1/2. So that's the third example. Now, this is the form ax to the n, and like I said, that's a convenient form in calculus. It's not too well. It's not often that you'll get something that can just be written in this form. Sometimes you have to settle for a sum of terms that are in this form. So I want to write in the next examples, write the expression as a sum of terms in the form ax to the n. So we're going to have several terms added together, a sum. Now, sum and difference, it's okay to have subtractions. That's just a sum with a negative coefficient. So the form, though, is we have more freedom, because now we can write it as a sum of terms. Now, as a first example, and again, don't forget to pause. First example, suppose we have the square root of x times the quantity 3 plus x squared. and we want to write that as a sum of terms. Well, you might say, well, I see a sum of terms, 3 plus x squared. It is a sum of terms, but it's multiplied by something. And we just want to have a sum of terms, each term being in the ax to the n form. Now, so we want to have some things added together over here, and each one of those things has to be our convenient form. So the thing that comes to the rescue here is the distributive rule, and that's where that came into the title. We're going to distribute the square root of x through the parentheses, and when we do, we'll have 3 square root of x plus square root of x times x plus the square root of x times x squared. So that's the distributive rule. And that gets us to a sum of terms, which is what we wanted. We had a sum of 3 terms. Now we just have to make sure that each term is in the form ax to the n, but that's not very hard in this case. The first one is in that form if we just remember the square root of x is x to the 1/2. And then remember the laws of exponents. When you multiply powers of x, you add exponents. So this would be x to the 1/2 multiplied by x to the 1, and so that would be x to the 1/2 plus 1, which is x to the 1/2 plus 2/2 is 3/2. So that would be x to the 3/2. And then we copy down the first term again. And then we have to go to the third term. And the third term is the same type of thing, except we have x to the 1/2 multiplied by x to the 2. 2 is 4/2. So that would give us x to the 5/2. And so now we have a sum of terms, and each term is in the form ax to the n. In the first case, a is 3 and n is 1/2. In the second case, a is 1 and n is 3/2. In the third case, a is 1 and n is 5/2. So we've got terms that are in the form that we're calling convenient for calculus. Now, second example, again, pause and try it yourself before you listen to the rest of my babbling on. So, let's see, the next example is x squared plus 3 over 3x to the 5th. Now I want to write it as a sum of terms, and the terms have to be in our special form ax to the n. So, there's a couple of ways to look at this. The way I like to think about this is I have to remember a little algebra here. It's very simple algebra, that if you have a plus b divided by c, the whole quantity a plus b divided by c, that you can think of that, if you want to, as a sum of 2 fractions, a over c plus b over c. Because with the common denominator of c, if you added them together, you just have a plus b quantity over c. So that's a fairly simple algebra fact that you've known a long time, but that's exactly what we can use here. So in this case, the a would be the x squared, and the b would be the 3, and the c would be 3x to the 5th. So we'd have x squared over 3x to the 5th plus 3 over 3x to the 5th. Now, having done that, now we just try to simplify what we have. So the first term, the x squared, will cancel with the x to the 5th to leave me 3 factors of x in the denominator. So the first one simplifies to 1 over 3 x to the 3rd power. And then the next one, the 3's cancel, and we have just 1 over x to the 5th. So we're getting there. Now it looks like we're almost there. we just need to write this as a number times a power of x. So in this case, the number would be 1/3, coefficient would be 1/3. The power of x, we got 1 over x cubed. So 1 over x cubed would be x to the -3 power. So that's the first term. And the second term is even easier. It's just x to the -5. And so, again, we have a sum. Here's the sum of two terms, and each term is in our convenient ax to the n form. Now, the next example, example 3, I suppose it is, in this section, it's x divided by x squared plus 3. Okay? So now we have to write this as a sum of terms, and each of the terms is an ax to the n. So, I guess the first thing you try to do is think, well, maybe I'll use my algebra again, c over a plus b. And that's c over a plus c over b. Now, is that true? I mean, it kind of looks good. But if you were going to add these fractions on the right-hand side, you would have a common denominator of a times b, not a plus b. And then you would have bc plus ac in the numerator, and you would not get back what you started with here. Now you can also convince yourself it's not true by just taking almost any numbers for a, b, and c, and it probably won't work out. Stay away from ones and zeros, but if you take 2 for c and 3 for a and 4 for b, you probably find out that it's not the same. So that's enough to prove it doesn't work as well. But this is not true. So put a big cross through that equals. That's not true. So that really keeps us from taking the easy step here. We could have said x over x squared plus x over 3 and we'd be home free, except it's just not true. So you say, well, maybe I should try something else. Maybe I think of this whole denominator as x squared plus 3 all to the 1 power. And then I could bring it up and say x times x squared plus 3 to the -1 power. And that's looking promising. Okay? And it's looking more like what we want. But now we run into another algebraic problem. And the question is, so what can you do about this quantity to the -1 power? Can you say it's x to the -2 plus 3 to the -1? Question mark. Is that true? Well, times the x. I was just working on the quantity in parentheses. Well, again, if you tried to add this back together, if you got a common denominator, you won't get back to where you started. And again, if you took a number for x, say x equals 1, and then you'd have 1 plus 3 is 4, 4 to the -1 power is 1/4. But here you'd have 1 to the -2, which is 1, and 3 to the -1, which is 1/3. 1 plus 1/3 is 4/3. It's not 1/4. So this is not true either. So don't do it. Now, so we tried two things that look somewhat promising, and neither one of them worked. Now, perhaps then you think, well, maybe. Well, I started to say maybe we could take x over x squared and x over 3, but that's the same thing I said over here with the c's and the a and the b. So I guess after you struggle with this a little while, hopefully you don't do any of these things that I've just suggested, because they're not right. And so at that point you just wonder, Well, what can I do? And the answer is this can't be written in our convenient form. So the wise thing to do here is to just punt. You can't do it in the form we want. So sometimes you can't write the expression you have in the convenient form ax to the n, or even as a sum of ax to the n type terms. And so in that case you'll have to learn some other things, and that's why calculus is a 5-hour course. So hope this helps, and good luck in your calculus.